Hi there, good day. In this video I am going to show you how to write test-driven development TDD code in C++. Before I show you that, I just wanted to iterate through what is the meaning of test-driven development. Here is the way I will define the TDD. TDD is the way of writing production code where test code for testing the production code is written in advance. So before writing production code, we'll write test code, and there are few steps to do TDD. Let's look at these steps. Step number 1: write enough failing test code. When I said enough is subjective. It depends upon individual and teams. This failing test code could include compile time and runtime failures. The step 2 is to write production code to pass those failing test cases. Step 3 is to refactor production code and verify the same with existing tests. And step 4 is to go to step 1. So once we just keep on redoing this step unless we complete our desired software production. Now I'll show you a demo of TDD. The problem statement is that create a binary search tree in C++ using TDD. This is a picture of binary search tree which I have taken from Wikipedia, and I'll just code that the same in the TDD way. So let's do the coding. I'll just keep it open for reference. So here I am in my Visual Studio 2015. So let's say I'm writing the test code. So I'll just start with main. So now I have to first write the test code. So let's say my test step 1. So as I said, I need to create a binary search tree. So I should have something called B tree, which is my binary search tree, and I can have a pointer variable with BST. And I want to do it something like I need a function called make tree, which will take the elements. So let's say it's an integer and value is 8. So I have created this, and I'm writing the test case is BST is equal to null ptr, then I'll say cout BST creation failed, or otherwise I'll write cout BST creation successful. Now what I'll do, I'll try to compile this code. So let's say when I'm compiling, I'm getting the compilation errors because these strings are not defined, and yes, I'm getting the compilation error. So let's say for me this is the enough. That's the step 1 for me. So enough failing test code. This is the enough failing test code. Now I'll write the production code to pass those failing tests. Let's go back. So basically I'll have a struct B tree which will have int val, and since tree has left and right nodes, I'll say B tree star left comma right. Fine. So I still, when I build the code, still I have some failures because you can see make tree function is not defined. So let's define the make tree function. I'll say void, no, not void, it's return BST. So I'll say B tree make tree int value. So let's say I have returned null pointer. So now if I compile this code, looks the return. Okay, now when I compile this code, some mistakes. This is compiled, okay, and now when I run this, you can see it says BST creation failed. Now from compile time failure to we came into runtime failure. Remember, if you go back here, it say the test include compile time failure and runtime failure. Now when I'm writing production code, managed to get rid of compile time failure, but now runtime failures are still there. So to get rid of this failure, maybe I'll have to return an actual B tree. BST equal to new B tree, correct, and I'll assign BST dot val is my value, and BST the left and right I'll assign it to null pointer, and I just return it to return BST this function. And when I compile it, compilation is successful. When I do it, BST creation successful. So I passed a step 2. Now step 3 is that refactor the production code and verify the same with existing test. Now this is my test code and this is my production code. Whatever production code I have written, will have to see whether I need to refactor it. It may very well be the case that instead of I can just use just use a constructor which takes a value and it returns to me val and it says value, and I'm just using the constructor initialization list and with the null pointer. That's all over here, and here then I'll get rid of all these things. I'll just say return new B tree with value. That's all. So that's it. So basically after refactoring, my code looks much neater. So that's the idea of refactoring. While we are doing the step 1 and 2, we may realize that we can make our code better. So that's step 3. Okay, now we go to step 1. So here we'll just verify the same, compile and verify the same with the existing test as per the step 3. I've given a compilation successful. Yes, it's successful. Now other part of BST. So once I have created a tree, I should have something like insert node in the BST. What are the nodes are there? 3 and let's do one thing, right in sequence. 1 3 4 6 7 8 is already there, so let's say 1 3 4 6 7 and 10 13 14. Say 10 13 14. So this will be my test step 2. So if I compile, I'll get compile time failure as earlier. Now I have to create a function for this insert node. So what I'll do, I'll create a function called insert node which will take btree star bst and int value. So yes, now it's successful, it's working. Though we didn't have any implementation over here, it's still working. So we don't know whether this is failing. So let's go to step 3. Here I'll do print bst and we'll just pass the bst. Now print bst is not defined. I'll go and create a function called print bst. I'll take b pointer bst. So in this I'll just print it in order way. In order way will print the binary search tree in a sorted way. In order is left, root, right. So we'll start from here: left, root, right, this one left, root, right, then left is completed, root, then right, left, root, right. So it will be printing every number in a ascending order. So what I'll do, I'll just use a simple recursion. Dot left is not equal to null ptr. I'll again call print bst with bst arrow left, and in this case I'll print the node value equal to bst arrow val for sake of it, and if bst again for write, this is a very well-known and common logic for printing in order way. Dot write, that's all. Okay, so now I compile, things are compiled. You can see it's success. Now what I'm trying to do, I'm printing the BST. Now you can see when I say it, BST creation successful, node value 8. Even when I'm trying to print the BST, it's not printing the complete inserted value. That means we have to write the production code to pass all those things. So then we'll come back over here. So here I will come up with an algorithm to insert value in binary search tree. So let's say if value is greater than bst dot arrow value, then it has to go to right. Else if value is less than bst kind val, then it has to go to the left. And else, let's say we don't allow duplicate value. No duplicates, please. So here we'll have to say value is greater than, it will go to the right. We'll have to check if the node is there. If not, we'll create it. If it is there, we'll go to this node and check if it's right is equivalent or less than or more than this. So if bst right is not equal to is this null ptr, what we will do now, let's say first if it is equal to null ptr, we can just assign something equal to make tree with value and just break it out. Else bst will be bst right and continue. Similarly over here, if bst left is equal to null ptr, in this case we'll say bst create a left with make tree with value and break it out. Else what we'll do bst equal to bst arrow left and continue. And in this particular case, let's see, we'll break out anyway. Okay, so we have did this, and now I'm going to compile this. It's compiling, done, successful. Now I'm running it. So when I run it, yes, I am getting the print in ascending order, 1, 3, 4, 10, 13, 14, and everything is correct. So that's the way I did it. Maybe there are other things I can do, like maybe I can say test step 5 I can write, 4 I can write saying that I want to check with -1. So if -1 is allowed, and if I did -1, then I have to print again to check, just see out, just to differentiate. So I'll again compile it, it's working fine, and I'll see print again, it's printing -1. And let's say if our logic has to be that this should not be supported, then we'll have to change the production code saying that if value is less than 0, say invalid value and return. So I'm running the same case again. I just compile it, build it successfully, and now I'm printing it. It says invalid value, and again printing the same thing. So this is the way what we do in the test driven development code. We write the test code first, then the production code, then we refactor. Again, so these are the rules. You have to write enough failing test code, include compile time, runtime, failures, write production code, then refactor and go to step 1. And this is the simple demo of what I just did to show you how to write a binary search tree in test driven development way. Similarly, you can write the code for deleting the node, and that I'm just leaving it as of now. So that's pretty much it. So we already did the coding, and thank you very much for watching. Please follow for getting continuous update on that. Thanks a lot. Thank you for watching.